I mentioned last time rationalizing the numerator, I think, at one point. If not, maybe that's a different video, but it's okay. I will talk about rationalizing the denominator and the numerator right now. So first off, there is a rule in math, and it's stated above. I don't remember reading it, so I'll just say it right now, is that you cannot have a radical left on bottom unless explicitly told otherwise. Like I'll talk about in a little bit about an occasion where you can, but for the most part, like if you're simplifying, if you leave a radical on bottom, you are wrong. So to get rid of a radical on bottom, all you have to do is you have to decide what makes that number on bottom, in this case it's a 2, but what makes that number simplest to make out to whatever radical it is. Like for now, this is considered a square root, right? Not for now. This is a square root, right? So what is the easiest number that I can get 2 to become so that it becomes a square root? Well, most times, that's multiplying it by itself. But anything we multiply on bottom, we have to multiply to the top as well. You will remember, hopefully, that if you multiply 2 square roots together that are the same, you just get that number out once on bottom. As far as the top goes, radical 3 times radical 2, you multiply the numbers inside the radical, so you end up with radical 6. So this would actually be the simplified version of this equation. I didn't mention this, but I mentioned it before that we can split the radical so it goes on top and on bottom, which is what I did here. Okay? Next, we are talking about this cube root over here, and I'm going to clear this other stuff. Hopefully it's been there long enough that you could pause it or copy along. But cube roots are similar to square roots, except for now we need 3 things to go into the bottom. So once again, I'm going to ask myself, what is the closest cube root to 9? Well, hopefully you realize that that is 3 times 3, right? So, what is a third, or what is a cube root takes out sets of 3. So I need another 3 on bottom. So that this denominator ends up being a perfect cube. Yeah, so 27 is the closest perfect cube. There are other ways to reason that, but the way I like to think of it is I need sets of 3. Here's 2, so I need 1 more. Or if you just think of it like we did here, 4 is the closest square root. What is the closest cube? It'd be 27. However you get there, you still have to multiply by 3 to the bottom. So anything I do to the bottom, I also have to do the top. What is the cube root of 3 times 7? Or cube root of 7. They work out to that. Once again, I need to simplify the bottom here. This is equal to just 3, so I end up with 3 on bottom. And the cube root of 21 on top. Okay? Now, the only time that a cube root is, the only time a square root is allowed to be on bottom is when they ask you this question right here. And you can't see that because I forget that I can't control it all the time. Rationalize the numerator. This means, when you see the word rationalize, it means make it so it's not a radical. Whether it be rationalize the numerator or the denominator, it means make it so there's no radical, which then makes it easier for us to deal with. So, same way as before, to rationalize a denominator and or a numerator, you look at the piece that you're rationalizing and you multiply it by the conjugate, which, remember, that just means you take the sign and you change it. So, anything we do the top, we have to do the bottom. Hopefully you remember I mentioned this. When multiplying conjugates, this always happens. You end up with the first term squared minus the second term squared. That's what you get every time. And on bottom here, once again, sometimes you have to FOIL, but if it's just a number, all you have to do is distribute it. So you end up with 5 radical x plus 5 radical y. Hopefully you remember. Once again, I keep saying that, but if you don't, we can always talk about it. Ask questions. Feel free to ask questions. I know I'm doing these videos so you can watch them over and over again, but if you don't understand something, sometimes watching it 17 times isn't going to help. So ask me questions, specific questions, and we can go over it in class easier. Anyways, squares and square roots cancel, right? So I end up with x minus y on top, and that's a horrible y, and then 5 radical x plus 5 radical y on bottom. Okay? This is the only time, once again, when it says rationalize the numerator, that I can leave a radical on bottom. Going on, once again, pause, rewind, write down questions if you have any. When they say convert to radical notation, that means put a square root, a cube root, or whatever it is on it. So change the power, whatever it is, so it's a radical. Well, remember, we mentioned this, I believe, the bottom number is your radical. So that number goes out here, and I'm going to highlight that. Just like that. And an 8 to the negative 5th. But what's a negative power do? Hopefully you remember that it drops you down to the bottom. Then I would, if you can, simplify it. So, once again, with this, you can cube root first and then go to the 5th power, which is usually the easier way to do it if it works. So what is the cube root of 8? Well, it's 2. So I have 2 to the 5th. So I actually get an answer of 1/32. Okay? The second one is much simpler. That just is my radical, so all you have to do is do the 6 through the m. You don't need to put the 1 because the 1 is assumed, but you can put it there and still not be wrong. Once again here, that is your root. This is your power. Once again, if we're dealing with numbers, it is always assumed, unless you're told not to, that you should simplify. So what is the 5th root of negative 32? You can use your calculator. We'll talk about that in class. It's under the math button, though, in case you remember playing with it. But it should be negative 2. And then you square that. What is negative 2 squared? It is 4. Okay? Remind me to show you that in class, in case you've forgotten. If you remember, great. But just remind me, because I'm sure not everybody has. Convert to exponential notation. That just means change it from a radical to the power. Once again, this number goes on bottom, and I'm going to highlight it again, even though I just did the exact same thing. Those are the numbers. So it just becomes that. Then you should still simplify your radical. 3/6 simplifies to a half, and you'd be done. Same thing here. This is all inside the radical, and it's a 4th root. So I know the 4 goes on bottom. The 5 applies to everything, so it goes on top, and that one I can't do anything else with. Okay, the next little piece here, we're going to work on simplifying these and making them so they're a little prettier, because, having multiple things is not fun, especially when you have like multiple radicals. Multiple radicals should always be canceled down. Meaning this power here is like a 1/3 power. But this radical in here is like having 7 to the 1/2 power. So you actually end up with a power to a power situation here. And if you remember, power to a power you actually multiply. So what is 1/2 times a third? That would be 1/6. If it asks, depending on what the instructions say, it may want you to go back to this. Just read your instructions and be careful. Either answer is technically acceptable. This one here, it's the same thing as regular multiplication. Like for example, if it was x to the 5th times x to the 2nd, that would equal x to the 7th because we added them. Same thing has to happen here. You have to add these powers, which in order to add fractions, we hopefully remember, which I said again, I think I'm saying that a million times, you need a common denominator. So the common denominator for 2/3 and 5/6 would be just to make this one become 6, which means I multiply the top and bottom by 2. So I end up with 5/6 plus 4/6, which then becomes x to the 9/6. Once again, if you can simplify that power, you should. So this becomes x divided by 3 divided by 3 to the 3/2. Okay? Something we don't talk about a lot, but you'll need to know because I'm sure they'll show up at some point in college algebra. You notice how these bases are the same? If they're exactly the same, you can actually treat it exactly like this one, meaning I get x plus 3 because those are my bases with 5/2 plus a negative 1/2. Add them together. That gets me x plus 3. 5/2 plus a negative 1/2 should be 4/2 if I'm doing math right in my head. Which once again, if you can simplify, please do. Ends up as x plus 3 squared. And once again, unless the instructions tell you otherwise, leaving it as that, I'm sorry, I shouldn't have clicked that so soon. Leaving it as that is perfectly fine. Okay. Another thing you need to note, this one can be treated just like this because the radical 2 is just a number and I'm putting two of them together. So I end up with 2 radical 2 because I just have two pieces going together there. But you can only add them once again if the radicals are exactly the same. So here I have addition, but these radicals definitely do not match up. The cheap way to do this is to always look at the smaller number and wonder, what can I do to this that involves that number? Well, 25 times 2 is 50, right? So I could break 50 up in 25 and 2. What is the square root of 25, though? 5, right? And this is multiplied here, even though you don't put a multiplication there. There's all multiplication here, but you don't put that dot. But since it's multiplication there, this now just becomes 9 times 5, which would be 45 radical 2 plus 6 radical 2. Notice then that my radicals are the same. If they're the same, just like they were over here, I had 1 plus 1. Now I have 45 plus 6, which would equal a nice 51. Okay, so once again, we will do our problems in class. If you have any questions, feel free to let me know. All right, have a good evening.